Hi, in this video we will look at some of the early ideas on elements and atoms. We will then jump forward a few thousand years to the work of John Dalton and review his atomic theory, before finishing up with J.J Thomson and his plum pudding model of the atom. There have been many ideas on what matter, that is, the stuff around us, is actually composed of. The ancient Greeks, for example, believed that matter was composed of 4 basic elements. These were earth, air, fire and water. While some Greek philosophers even suggested the presence of a 5th element, which they called ether. Now, ether was an element that filled the heavens and was breathed in by the gods. However, Democritus, another Greek philosopher, suggested that matter was composed of small, invisible and indestructible particles called atoms or atoms. However, most Greek philosophers, including Plato and Aristotle, rejected these ideas. However, these ideas of the Greeks were simply that, ideas, and none of them were ever tested by experiment or observation, but relied solely on reason, thought and logic. Though some of the ideas of Democritus did contain a grain of truth in them. John Dalton, an English scientist, proposed his atomic theory in 1803, but unlike Democritus, his theories and ideas were based on experimental work and analysis. Dalton also used the work of many other scientists to help develop his ideas and thinking. According to Dalton's atomic theory, all matter is composed of indivisible particles called atoms. Now, Dalton, like Democritus, imagined atoms as solid indestructible spheres or balls. In fact, Dalton probably imagined atoms as being similar in many ways to billiard balls. Now, Dalton's atomic theory consisted of some key ideas that were the foundations on which the modern idea of atoms and their behaviour are based. For example, all atoms of a given element are identical in size, mass and chemical properties. Dalton proposed that elements are composed of unique atoms and that all the atoms of the same element are identical. So, for example, all the atoms of iron are identical to each other, but were different to, say, atoms of the element sulfur, which of course were all identical to each other. Dalton also suggested that compounds are formed by the combination of atoms in simple whole number ratios. According to Dalton, chemical reactions involve the rearrangement of atoms, but the atoms themselves remain unchanged. So, for example, when the carbon and hydrogen atoms in methane react with oxygen to form water and carbon dioxide, all the reacting atoms rearrange themselves in new ways to form compounds, but the atoms are essentially still present and can be reformed from the compounds they have formed. Though Dalton had no means of measuring the masses of individual atoms, he compared the masses of other atoms to the lightest known element, hydrogen, which was given an atomic mass of 1 unit. From his experimental work, Dalton was able to measure the masses of many elements and compounds by comparing their masses to the lightest known element, hydrogen. From what we have seen so far, both Democritus and Dalton both imagined that atoms were solid, indivisible spheres that couldn't be further split or divided. However, following the work of John Joseph Thomson, a physicist working at Cambridge University, this model of the atom was about to change. In 1897, Thomson was experimenting with cathode ray tubes. Now, these are essentially just long glass tubes in which most of the air has been removed using a vacuum pump. If a piece of metal is placed in the cathode ray tube and a large voltage applied across it, then a stream of particles is emitted from the metal cathode. At the time, Thomson called this stream of particles a cathode ray, since the ray was emitted from the negatively charged metal cathode. Now, this stream of particles, or cathode rays, were then accelerated at very high speed up the glass tube by the attraction to a positive anode. The anode contained a small slit through which the particles or rays could pass, and this would produce a narrow beam which struck a fluorescent screen on the end of the tube, causing it to glow green. Now, if two charged plates are placed in or close to the cathode ray tube, the cathode ray is bent away from the negatively charged plate, indicating that the rays or particles in it have a negative charge. Thomson concluded that the beam or cathode rays consisted of small, negatively charged particles, which he called corpuscles, a name which was later changed to electrons. As a result of his work, Thomson suggested that the atom was not a solid, indestructible sphere, but consisted of a cloud or sphere of positive charge in which electrons were scattered. His model of the atom is often called the plum pudding model. Now, a plum pudding is usually served only at Christmas, and it is a thick cake with raisins scattered through it. In this model, the raisins would represent the electrons and the cake would represent the cloud of positive charge. Hi, thanks for watching. If you found this video helpful or would simply like more information, then why not visit the website that accompanies these videos? The links are in the description below. If you enjoyed the video, then please consider liking and subscribing. Thank you.